Hey, Sam here. Let's do another Daily Leetcode question together. We're doing number 506, relative ranks. I have a timer, which I'm going to start on time for once. So you're given an integer array of scores of size n, where each score is the athlete's score in that competition. All the scores are guaranteed to be unique. That's nice. Athletes are placed based on their score. Gold, medal, silver, bronze for each rank. For the fourth place onwards, it's going to be just a string of the integer value. So score 5, 4, 3, 2, 1, gold, silver, bronze, 4, and 5. And that's just that ordering. So we could just do some sort of sort perhaps. However, here, gold, 5, bronze, silver placements. All right, this one is actually kind of tricky, I think, because it sounds simple. I've done something like this before where you have to do the rankings, the sortings, but you're keeping the original order. And that's the part that's kind of tricky, because if I were to just sort these scores, I actually need their indices, which is more important. And we could use something like NumPy argsort. So let's start talking about that. We know with constraints that this will be at least one, and it'll fit in memory. Values will be integers that exist, and all the scores are unique. That's nice. And n will always be the score length. Not that it matters here, because we are just given the score, and we're going to give an output of list. So ideally, at least on time and space, because you have to go through every value no matter what. We're going to be doing some sort of sorting. So I think we're going to be at least on log n. I don't know if we can do linear time for this problem. Let me know. Yeah, I don't know if there's any way to not sort better than this. Let me know. Okay. So what I'd like to do is I'd like to get scores sorted in order biggest to smallest, and then the index is the rank. So let's say 5, 2, 3, 4 is going to be ranking is 0, 3, 2, 1, something like that, because it'll be fifth score is the best, first score is the second best for 4, and so on. And then eventually we'd want to go through the original list, knowing that the 5 has a score of 0, 2 has a score of 3, 3 has a score of 2, and 4 has a score of 1. And guess what? This is going to be a dictionary of score to ranking. I don't like that they call this score, so I'm just going to call it scores to make it easier for us. What we can then do is iterate over scores, convert ranking, get ranking from dict, convert ranking to string, and that'll be our output. I think that's the whole process. Generating this array dictionary will be O of n times space. Generating this ranking will be on log n for quicksort, for sorted. That's what Python uses. Not sure if there's anything better with, say, max heap or something like that here. Can't see how that would change. Maybe that's slightly more optimal even if it's on log n. But you have to get the whole ranking, which doesn't make sense. Max heap is most useful when you only need the first x or k values out of a array sorted, not the whole thing. So that's not the case here. We're doing everything. Okay, let's get the rankings. It's going to be just sorted of scores, and that'll give us our sorted array. And then we'll create a dictionary. Let's call it that. And then we'll call maybe ranking. It's going to be a dictionary of the score to rank, or score rank in sorted scores, and rank is the index, so we're actually enumerating this, and it'll be rank score in that case. And I want the rank to be 1 index rather than 0 index, just to make the next change a lot easier. 1, 2, 3, 4, yeah. Okay, so we have a ranking from score to that rank, and in fact we could even inside this loop do the converting it to a string, so maybe let's do that. So for rank in there is equal to rank plus 1. Ranking is going to be our empty dictionary. Let's do it that way. Sure, why not? If rank plus 1 equals 1, then we have our... Actually, don't even need to do plus 1 here. If that's 0, then it's going to be a gold medal. And then elif silver, bronze, else. There'll be a string. and this is where you +1 it. So now we have a ranking dictionary that gets the actual rank out, and now we'll just iterate over the whole array for score and scores. Actually, we could probably return this directly. Ranking of score for score and scores. And I think you could even do this another way where you could map ranking. Is that allowed? I don't actually know. But then you'd have to convert this to a list at the end of this anyway. So I don't actually like that. That feels a little, well, one could argue it looks a little cleaner. I think this one will actually end up being a little faster. So ranking score score, and it's already converted it to gold, silver, bronze, or the string value. So 4 gets to 4, sorry, other way around. Okay, can't think of anything else. We're about 7 minutes in. Feels okay. This is O of N. Building this dictionary hasn't actually even happened and is being built here. This is O of N, O of N. This is O of N. Pulling from the dictionary is O of 1 amortized. Generally O of 1. Alright, let's try running it and see how we do. Any edge cases I can think of? Well, there were a couple. Ooh. Oh, right, it needs to be reverse order. If you all saw that, sorry about that. Gotta keep track of the ordering. Max first. Alright, let's try that again. Okay, never mind, just wrong. Okay, it is right. It is right. It's just I need to capitalize the M in metal. My apologies to everyone. If you were seeing that before I did, that was pretty silly of me, but not a big deal. Interviewer wouldn't mind too much, but it's good to pay attention to the details. Okay, anything else we can think of? What happens if we had just one value? Would this fail, or would this still succeed? And would this fail for just a single value? Nope, it would be the same ordering. It would return gold. Doesn't care if there's not enough. I think we should be good. Okay, let's submit and see how we do. Come on. Yes, very, very cool. Yeah, we did it. And it looks like there's a bimodal distribution here. I can see if you didn't use a dictionary, you did like a O of N sweep, you could do some sort of O(n) squared type approach without sorting then. That would probably be what this one is. I should have considered that, just to point out brute force, O(n) squared, loop, double loop. Actually, it'd be O(n) log n times n. Yeah, n squared still. So let's not do that. Cool, I'm very happy with that. Super fun, nice simple question. Hope that was interesting to everyone watching, and see everyone next time. Cheers, thanks for watching.